Okay. Good afternoon, good morning, ladies and gentlemen and dear colleagues. First of all, I would like to thank the organizer, ICTP and Harvard University, to invite me to be in this interesting workshop. My name is Soichiro Yasukawa. I'm a chief of the Disaster Risk Reduction Unit, Natural Sciences sector in UNESCO. And I would like to discuss with you today how we can use this device, TinyML, for disaster risk reduction or climate change adaptation. I just listened to part of the previous presentation, but I'm very encouraged to hear that there is already, ideas how this tiny machine learning device can be used for DRR and climate change adaptations. So today I would like to use this opportunity to share with you what UNESCO is doing on disaster risk reduction, and also I would like to spend some time how we use artificial intelligence, not this TinyML, but artificial intelligence in general to the disaster risk reduction and climate change. And lastly, yes, I would like to share some of my idea how this device can be used for disaster risk reduction. But I have to say that I'm not an expert on this, so my some suggestion might be not relevant or technically correct. But anyway, I would like to discuss with you how we can use this device for the DRR. So I don't think I need to repeat why disaster risk reduction is important, but obviously there is a lot of human loss or economic loss by natural hazard. So there is like official data like last 20 years. We had like 1.4 trillion US dollars damage or 1.3 million, deaths by the natural hazard for the last 20 years. And below is interesting data. Left one is a number of disasters per type, and right one is a number of deaths by different hazard. So we always say that 90% of the natural hazard are weather related. Yes, it is true. We have flood, storm, extreme temperature, and so on. But at the same time, if you look at the number of deaths by different hazard, actually earthquake is the biggest one, around 60%. So I don't mean to say which one is more critical, but if you look at the numbers from different point of view, we could see a different, issues on the natural hazard. So this is what UNESCO's disaster risk reduction. UNESCO is a UN agency which has a mandate on natural and social sciences, education, culture, and communication information. This is why we can take a multidisciplinary approach on disaster risk reduction. And also we work on tsunami, flood, drought, earthquake, landslide, so we can say that we work on the multi-hazard way. And the UN organizations, normally we target the government for policymakers, but UNESCO also try to engage with academics or civil societies such as youth or gender issues, and also civil societies and the private sectors. So we could say that we are working on the multi-stakeholder participatory approach. And you see, although it's very small, we have like 8 different thematics on disaster risk reduction services for the countries. The first one is STI, Science, Technology, Innovations. Second one is Early Warning System. Mostly this tiny machine learning or artificial intelligence fall into this our thematic approach. First one STI and also second one Early Warning System. And UNESCO explores both conventional and innovative solutions. Yes, there are some tools which are widely used, but at the same time, UNESCO is always exploring innovative solutions which could change the approach on disaster risk reduction and climate change adaptations. So using artificial intelligence or using tiny machine learning devices are one of the approaches we want to take on UNESCO's DRR and climate change adaptations. And UNESCO's priority areas, yes, this is under the midterm strategy of UNESCO, Africa, gender, small island developing states, and youth are our priority areas. We have a headquarters of UNESCO is in Paris, but we have 53 field offices around the globe, and all the most of the field offices are working on disaster risk reduction or climate change adaptation activities. So these are some of the key projects around the globe, but the one project in red are the one which we utilizes artificial intelligence. And I would like to share with you some of the project which uses artificial intelligence before I share with you my idea how we can use tiny machine learning devices for DRR and climate change. So first one is using artificial intelligence for flood forecasting using artificial intelligence. This is a project in West Africa to do the flood forecasting. We use artificial intelligence of the artificial intelligence. We use a function of image analyzing of artificial intelligence to do the flood forecasting. So in these countries in West Africa, we don't have much surveillance monitoring stations on the ground, so we need to count on the satellite data. So with this satellite data, we utilize artificial intelligence image processing to identify the high risks of flooding by the two big rivers, Volta River and Niger River in the West Africa. So this one is we use the function of image processing for the flood forecasting. Second one also in Africa, but this one is Southern Africa. This is also a flood forecasting using artificial intelligence. But in this project or in this program, we use artificial intelligence for better reasoning or better regressions models for the forecasting of flood. So we combine the past data and current data to forecast the next 24 hours floods by using AI for better regression models. So this is a second examples we use artificial intelligence. And third one is a risk communication tool with mobile applications, AI chatbot. This is also in Africa, but this is in East Africa. So this one is to facilitate the communication between citizens and the policymakers, how they can share the information better. Because during, before, during, after flooding or cyclones, people want to know where to evacuate, where they can support, where they can get some food, etc. But information on the internet, it might be difficult for the citizens to identify the correct information. So in this AI chatbot, which we use the language processing function of artificial intelligence, so that citizens, so this one is we use Line. Line is like a WhatsApp, which is used in Japan, and So it's really like a WhatsApp or other mobile applications for social network. And we become friends with the cyclone A or hurricane B, etc. And then the citizens, the users can just ask questions like where to evacuate or what is a forecast, what is a forecasting of the flooding and so on. Then AI chatbot will find the correct answers using this language processing of the artificial intelligence and then provide answers to individually. So if you see on the right side of this presentations, yes, a user can ask questions and then AI chatbot will answer you the questions. Of course, in order for the artificial intelligence to answer, there is an answer somewhere in the public sectors and so on. This one is also this project is will be in the Dominican Republic to use artificial intelligence for optimizing the decisions, optimizing the decision making. So this project is how to minimize the disruption of education in case of natural hazard like a flood or cyclone, etc. Because when the natural hazard happens, the school building might be damaged so that the people cannot continue the education, or the associated critical infrastructures like transport or lifelines are damaged so that people cannot use the school buildings. Or sometimes after the natural hazard, people use school building as a shelters. So we have a different element to consider to continue the educations. So we are going to add all the information for the building information and also the infrastructure information and also the contingency planning of the schools, how they use the school buildings to shelters or not. And then we use a probabilistic approach. Then they will identify the risk of disruption of the education. And also with this tool, we could identify the optimized investment either to school building or infrastructure. At the same time, we can make like a contingency planning in the city with 100 schools, which schools to be used for shelters, which schools to be used for education, and so on. This one, yes, we have still in the beginning of the project, but this one is the project which we use artificial intelligence for the disaster risk reduction and climate change. But in UNESCO, outside of DRR and climate change adaptations, we have many activities for using artificial intelligence, and this one is about this tiny machine learning devices. And I bet you know better than I do, but this device can catch the sound or vibration or visions, so that there is big opportunities to, and also this is it doesn't consume too much electricity, so this has a great opportunity or potentials to use for the DRR and climate change. And I already heard like a flood early warning system or land use, and landslide forecasting, or I heard about fire detecting, wildfire detecting. This is not DRR climate change at all, but we also developed mobile applications which uses image recognition of artificial intelligence. So in order to promote geoscience, so if you go to a hiking and you see some stones and then you take pictures, and then this application will tell you the history or background of this each rocks. Yes, okay, I thought I put more information, but lastly, I would like to share with you my, quick thought how we can use this TinyML device for DRR and climate change. It's already, yes, it's already, there was already a presentation for flood and landslide, yes, but I think we can use this devices for monitoring or detection of natural phenomena like a wildfire, drought, flood, or earthquake and landslide. I don't know exactly how, but I believe that the participants today have a background of using these devices. So if you wish, we could do some discussions even later or today how we can use these devices for detecting or monitoring the phenomenon. And the next one, I think a previous presenter already mentioned, but we can use these devices for health monitoring of the building or infrastructure. No, especially targeting for earthquake, because I think in the beginning, when the building was constructed, I think it's supposed to be safe against natural hazard, but time to time they received some earthquakes or hurricanes, and then the building got damaged. But if we put these devices on the major structure of the building, and then they always detect this small vibration of the project, maybe it could tell us that in certain moment, the vibration pattern might change after a small earthquake. Then maybe we could identify the critical elements of the building which is damaged by the earthquake or hurricanes. So if we put these devices on the building somewhere, in the building and keep continuing the vibration monitoring, then it could help to identify some damage of the building. And also, yes, I thought about maybe we can combine the drone and also tiny machine learning devices to, I don't know exactly how, but if they start to, fly with this device, then yeah, it could do something, right? Because normally we do a risk assessment of the bridges or schools by by the human experts, but maybe tiny machine learning can detect some visuals to see the damages on the bridges or tunnels, etc. Last one, this one is also, I don't know exactly how we can do that, but maybe we could use, because tiny machine learning so far we are exploring the possibilities for more like a scientific monitoring or technical part. But at the same time, on disaster risk reduction, it is important that people take actions. People understand the risk and take necessary actions. So people need to change their behavior. People need to change their mindset that they need to prepare, they need to evacuate, and so on. I don't know exactly how, but maybe these tiny machine learning devices can help this alerting people, for the individually to take necessary actions for DRR and climate change. So yeah, so I think this is my idea, but just a quick thought that I would like to discuss with you the possibilities of this device and DRR and climate change. And this is my last slide. we say that if we invest $1 in a disaster risk reduction, then we could save up to $50 for avoided losses and reconstructions. So it's better that we take actions beforehand. Beforehand, the natural hazard happens. And there is a two QR code. If you are interested in, please connect to this. One is our webpage. One is our posters on our program. Thank you very much.
Thank you very much, Soichiro. Very interesting presentation. There were some comments in the chat and also through private comments. So they're asking about your slides, if you can share the slides afterwards, because I think a number of participants are working in this field. So we just had a presentation from Reginald from the Philippines, which has a long experience in setting up IoT systems for flooding and for earthquakes and weather and environment and so on. We have Apinu from Thailand, which is also active in this field and wants to collaborate. So I have one comment and one question. So the comment is that another field where I think TinyML has a role to play is this in this multilingual kind of approach. So we worked on day 3 about this on this application, which is called keyword spotting, where you can detect specific keywords and then you can act upon what if you detect these keywords, like hi Siri or like Google, as we normally do. But now you can do this in these really tiny devices, and you can do it in local languages. So I think that aspect is also very interesting, because again, with these very low-cost devices, distributed low-cost devices, you can understand what local people are saying in their own languages. So that was my comment. And my question is, how do people get in touch with you if they want to, interact with UNESCO on these topics?
Just email me. Maybe I just. I'm just typing my email address. Yes, no, please feel free to contact me so that I can engage with you for brainstorming, etc. And yes, I would be happy to do so. No, thank you, Marco, for your comments about this multilingual, detecting. But so this device, how do you detect, people's? Is it like you detect the people's talking, or on the social media and so on?
So these devices can detect specific words. So they're listening all the time, and then they just pick up if you say something specific, like again, Siri, if you have an Apple device. And so I'm thinking that maybe one could have a system that detects in local language some specific words, right? Thinking about, flooding or heavy rain or something like that. And there is already some projects where they do that. They did it in, I believe, in Tanzania. It was on a kind of different issues, but these kind of projects could be done.
Okay.
I don't know.
Because maybe in the shelters, etc. Maybe you place this devices, and then maybe they could detect like their needs, etc. Because in the shelters, I think for the first 3-4 days they need water, they need a blanket, but then they gradually want to have they want to eat warm food and fruits, and then sanitary things, etc.
Something else that comes to my mind is one could have this kind of automatic system where you ask a question to people in local languages, and according to what they say, then you do something else or you ask some other questions. But being able to do that kind of thing in this really, $5 device, I think is a kind of a game changer, right? So one could ask, I don't know, do you have issues with, I don't know, your family? And they say yes or no. And then depending on what they say, then you can ask some other question, and then maybe you can guide them in case of an emergency. Just an idea. Let's see if Reginald or Apinum, if you have, or other participants, of course, if you have any comments or any questions for Soichiro in this kind of brainstorming session, or Adi, of course. I mean, you mentioned drones, and Adi from Malaysia has a experience in using LoRa on drones, right?
Hello. Yes, you're right, Marco. So to Soichiro-san, we did quite a number of works by using drone, and one of them, we mount a LoRa gateway on the drone so that we can collect all these sensors data from the livestock, for example, like the cattle on the ground. So this kind of solution is applicable if you're looking at a very wide and huge kind of livestock monitoring for industrial use, for example. So we also developed these sensors to collect the radiation, the ionizing radiation exposure on the background, focusing on safety-related aspect to the public related to this ionizing radiation due to industrial. So that's another project we are looking into. And we are at the stage where we try to predict the abnormality or the search of the reading through the use of TinyML, but it is still at preliminary stage. Yeah.
Yes, I think so. Yeah, because this device can also capture the images, and I think working with drones and it will be great. It will be great, and they could judge or analyze something immediately in the sky and send us some information.
Excellent.
What they can even, when the tsunami is approaching, but they can use this drone and also these tiny devices to flying around the coastal areas and to warn them. I don't know if they have sound in itself, but you can specify you can identify the people on the coastal lines to encourage them to evacuate, something like this.
Reggie, do you have any comment about this local language issue? How is that managed in the Philippines? Let's see if Reggie is still around. Maybe he's not. Oh, yeah.
Sorry.
Okay.
Sorry.
Yeah, it's okay. It's okay.
Okay. The language monitoring is very critical for. It could help people experiencing human trafficking, just like what you said a while ago. A person can ask a question or a TinyML, and the TinyML could detect or predict if a person is under threat, so that proper intervention could be applied to that person by the authorities.
Excellent. So I think we have some ideas floating around, and I'm I hope we can, maybe get started with a pilot in one of the Asian countries through, UNESCO's, projects. That would be really nice. And again, I think that, compared to other AI and machine learning like architectures, from my point of view, the advantage of TinyML is that it is really sustainable, because again, these devices don't require connectivity, and the cost is really, really limited, and the power consumption is really low. So they seem to have all the right ingredients to make it scalable, and that's sustainable. Excellent. So if there is no more questions for Soichiro, so a round of applause for you. Thank you very much for the presentation.